In this video, we want to work on an example together on the hypothesis test and the mean of the normal distribution when we don't know the variance of the population, like sigma 2 is unknown. So here is a question. It might be a good idea if you pause it here and read the question that you can see, and then come back, and then we can work on it a little by yourself, and then look at the rest of the video, which is like I'm going to go step by step. So in the question, when you look at it, it's like that we know that we are looking for the mean of the normal distribution, and when you read the question, you see that we don't know the value of the sigma of the population. So what are we going to say? We would say that we are in the second category, right? And for the hypothesis test, the parameter of interest is mu, and sigma 2 is unknown. So when sigma 2 is unknown, it's the same as we say that, for example, sigma is unknown as well, because one is variance, the other one is the square root of the variance, which is a standard deviation. So I can say sigma 2 is unknown, or even sigma is unknown. Both are the same. So we have the first step, which is the parameter of interest. And when I'm looking at the question, it's like that I have the sample, and I can find out the amount of the X bar and a standard deviation from it. So, and then I would put it in the test statistic. But the second step is that says that state the null hypothesis. So we know that the mu, which is the mean coefficient of the restitution, so we would say if our mu is equal to we need to find out the amount of the X bar for it here, for later to compare it, right? But for when you look at the question, it's like that for your null hypothesis, your mu is equal to 0.82. I'm just looking at the question. And your alternative hypothesis here is one-sided. It's not two-sided. We want to reject the null hypothesis if the mean coefficient exceeds this number of the 0.82. So we have upper-tailed one-sided. So it would be the alternative hypothesis can be mu greater than 0.82. So that's my alternative hypothesis. Then it says that choose your alpha. So our alpha is, I'm going to write it down here. Alpha is going to be equal to 5%, 0.05. And then in the next step, we want to write down our test statistic. So it's like, here is the test statistic, 5. So step number 5 is going to be my test statistic, appropriate test statistics. And we know that when we are on the second category, so we are looking for the T null, and our T null is X bar minus mu divided by in the denominator, we don't know the variance of the population or standard deviation of the population. So we will write down S over the square root of n. And we know these values, right? So in the step number 7, we are going to compute this T null value, the value of this T null. Okay. Number 6 is that we want to find out our rejection criteria. So for the rejection criteria, state the rejection region. So we want to see that what's the criteria that we have is that we want our mu, and the null hypothesis says that mu is equal to 82%. And alternative hypothesis is the time that mu is greater than this 82%. So what are we going to do for the rejection region? We would say that we are going to reject the null hypothesis if our t, the value of the t at the 0.05 and n minus 1, so whatever n that we have, the sample size that we have, minus 1, so the sample size was 15, the n minus 1 is going to be 14. We are going to put it later. So if our t null is greater than this value, so if t null is greater than this value, we are going to reject the null hypothesis. And when we go to the table and find out the t of the 0.05, n minus 1, we said that n is 15, I think, when I look at the question. Yes, so n minus 1 is going to be 14. From the table, I will find out the value of this one by looking at the table. So it's like we're looking for the t distribution table. So with the t distribution table, when you work on it, it's like that. You can see that on top you have your alpha, and then here is the degree of freedom, or nu, which is n minus 1. So I know that my degree of freedom is 14. I would look at it here as 14. And then from here, I'm looking for 0.05. I would go down, and then for the 14, the value that we will find out for t is going to be 1.761. So I'm going to write down here 1.761. So if my t null, which is this one, if it was greater than this number, 1.761, then I would say that I'm going to reject the null hypothesis. So that's for the step number 6. Step number 7 is the computation. So when we are working with the computation step, we would say that, okay, so basically in computation step, we are going to find out the amount for the t null. So for this one, we need to put all the value, like we found the x bar, we found s from our sample size. So here, we need to find out x bar from the sample. So the x bar, when we calculate it, is going to be 0.83725, 83725, and then we need to find out our S value, standard deviation from our sample. So S is going to be equal to the 0.02456. And our n is 15 as well, as we said. So from here, n is 15. When we put it, so we have our mu is 0.82. We have our x bar from the sample, and we have s and n. So from these three numbers, we substitute that in this equation, and we can find out the value for t null. So the value for t null is going to be equal to 0.83725 minus 0.82 divided by the 0.02456 over square root of 15. So the amount is going to be 2.72. Yes. 72. Step number 8 is that we want to compare the value of the t null with the value of the t from the table for the alpha of the 0.05 and n minus 1, which was 14, right? So we are going to compare this 2.72 with 1.761. So we will see that our t null, which is equal to 2.72, it's greater than t of the alpha, t at alpha and n minus 1. So from here, when we say it's greater, it's like that we are going to reject the null hypothesis. So we would say that because of that, we are going to reject the null hypothesis. And when you look at it, we just use this space. If you want to look at it on the figure of it, so look at this one. Here is like that, it's one-sided. And when it's one-sided, we said that it's like that, it should be greater than some number, right? It's like our mu is greater than 0.82 is our alternative hypothesis. So it's like that. I'm here. So my t, there is 0. So my t from the table for this amount of table, this is alpha, right? So this is alpha. So for the t value for this 0.05 with the degree of freedom of the 14, it's going to be 1.76. When I'm looking at the value of the t null, which I found is 2.72. So when this one is 1.76, it's like that your t null is going to be here. So when you look at it, this is the t null. So we are in the rejection region. So even if you look at this one, you can say that, okay, so we're in the rejection region, and we are going to reject that reject the H null that we have here. So with this one, in fact, we can say that, we can conclude that at the 0.05 level of the significance, that the mean coefficient of the mean coefficient that we have here, it exceeds the 0.82, right? So we are in this one. So we reject that it's equal to that one, or it's less than that one. In fact, it's like the mu is greater than 0.82. So that's the example we worked on the example of the second category.